A very good morning to one and all, and I am very happy to give a small lecture on signals. And we all know about signals. Signal plays a very vital role in communication and other parts of our life. And what is a signal? Any physical quantity which varies with respect to time is called a signal. So it may be a volume, it may be a temperature, or it may be anything, but it should vary with respect to time. It's called a signal. And there are different types of signals available. The best example for a signal is our voice signal. So our voice is an analog signal. My voice is an analog signal, and it is also called as a continuous signal, and it is also called as a low level signal. It is also called as a baseband signal. So this is also sometimes called as audio signal. And similarly, there is one more signal, that is digital signal, that is discrete signal. So the difference between this analog signal and the digital signal is analog is continuous in time, digital discrete in time. So the main idea of today's talk is about to differentiate these two, analog and digital signal. And if you process an analog signal, then it is called analog signal processing, and if you process a digital, then it is called a digital signal processing. And we all know these two signals plays a very important role in the field of medical field, in the field of defense, in the field of satellite applications, other wireless communication, 3G, 4G, 5G spectrum applications, where this signal plays a very important role, and there are multiple applications using this signal. And later on, after the development of digital signal processing, there is an advantage of using a multi-rate signal. So what is the difference between a normal signal processing and a multi-rate signal processing is, suppose if you want to store a signal, the data can be stored, it can be compressed and it can be stored, and again it can be decompressed and it can be used. So a normal signal, that is a digital signal, cannot be used as a compression, decompression, that is interpolation and decimation type, whereas and these multi-rate as this type. So whereas a normal signal has a single sampling rate, whereas a multi-rate will have multiple sampling rate. That is why it is called multi-rate signal processing. So after the development of this, there comes the wavelet. So before the wavelet, there is a signal called sync signal, that is sin theta by theta. That is also called as a window function. So this window signal is nothing but it has a main lobe followed by side lobes. The total energy of the signal will be stored in the main lobe, and the side lobes will tends to 0 as omega tends to pi. So there are different types of signals, and these digital signal lateral, it can be used for, now it is used for medical applications where it is called ECG signal, electrocardiograph signal, AMG signal, electromyograph signal, EEG signal, electroencephalograph signal, PCG phonocardiograph signal, RCG retinocardiograph signal, and so on. So all these signals will play a vital role. So with using of these signals, we can use quite applications, and these signals plays a vital role in all the applications of day-to-day technologies, where artificial intelligence, where VR, AR, where you can use it for applications like low-code applications, and all other developing technologies will use these signals, and we should know about the signals. Last, there is one more signal called fractal signal, where the fractional dimensions of any system can be analyzed by using these fractal signals. And hope this topic will help you for the analysis of signals. Thank you.